Hello students, welcome to Saurav Sir's classes. The question is, let x1, x2 up to x100 be IIT random variables with expectation x1 is 0 and expectation x1 squared is equal to sigma squared, where sigma greater than 0. Let s is equal to summation xi, where I goes from 1 to 100. If an approximate value of probability s less than equal to 30 is 0.9332, then sigma squared equals. Now we have been given that expectation x is equal to 0 and expectation x squared is equal to sigma squared. Thus, variance x would be expectation x squared plus expectation x whole squared, that is sigma squared plus 0, which is equal to sigma squared. Now, since s is equal to summation xi, where I goes from 1 to 100, so expectation s would be summation expectation x, that is 0, and variance s would be summation variance x I, where I goes from 1 to 100. Now since these are IIDs, it would be 100 into sigma squared. Now by CLT, s follows normal 0, 100 sigma squared asymptotically. Now we have been given that probability s less than equal to 30 is equal to 0.9332. That is probability s by 10 sigma less than equal to 30 by 10 sigma. So this becomes z, that is a standard normal variable. Now you will notice that we have just divided by the standard deviation, and since the mean was 0, even if we would have subtracted 0, it would have remained the same, so I didn't write the step minus 0 over here in both the cases. So probability z less than equal to 3 by sigma is equal to 0.9332. That is phi 3 by sigma is equal to 0.9332, and 3 by sigma is equal to phi inverse 0.9332. Now from standard normal tables, we will get phi inverse 0.9332 to be 1.5. Therefore, sigma is equal to 2 and sigma squared is equal to 4. So sigma squared equals 4 is the answer. The next question is, let x be a random variable with the probability density function lambda to the power r by r minus 1 factorial into x to the power r minus 1 e to the power minus lambda x, where x greater than 0, lambda greater than 0 and r greater than 0. If expectation x is equal to 2 and variance x is equal to 2, then probability x less than 1 equals. Now, this PDF can be written as lambda to the power r by gamma r x to the power r minus 1 e to the power minus lambda x. Thus, x follows gamma r comma lambda. Now, expectation x is equal to r by lambda is equal to 2 and variance x is equal to r by lambda squared is equal to 2. Thus, using equation 1, r by lambda into 1 by lambda is equal to 2, or 2 into 1 by lambda is equal to 2, and we get lambda to be equal to 1. And putting lambda is equal to 1, we'll get r is equal to 2. Now, probability that x less than 1 is equal to 1 by gamma 2 x e to the power minus x dx, where x varies from 0 to 1. Now gamma 2 is equal to 1. Therefore, this becomes x e to the power minus x dx from 0 to 1. Now continuing this over here, so this becomes x e to the power minus x by minus 1 minus integration from 0 to 1 e to the power minus x by minus 1 dx, limits from 0 to 1. So this is minus x e to the power minus x minus e to the power minus x, where limits vary from 0 to 1. So this becomes minus x plus 1 e to the power minus x from 0 to 1 is equal to minus 2 e inverse plus 1, that is 1 by 2 minus e, which is equal to 0.2642. Thus, the required probability is 0.2642.